Hi, ladies and gents. This time we're going to talk about something called allotropes. Now, allotropes are defined as different pure forms of the same element. Not all elements have allotropes, but some do. And the one that is the most obvious that you and I have seen pure forms of the most often is carbon. So an allotrope is a pure form of an element that just is bonded differently. The atoms are arranged differently, and this different structure is going to give these different pure forms different physical and chemical properties. So let's take a look at the allotropes of carbon because these are so interesting. One of them is graphite. If you are taking notes right now using a lead pencil, there is no lead in a lead pencil. It is graphite. So it is a pure form of carbon. Actually, in a pencil, they add a little clay as well to give you the difference between a number 1, 2, and etc. kind of pencil, how hard it is. But the smeary bit that leaves a mark on a page is actually carbon. And it is arranged, the atoms are arranged in graphite in little rings, little six-sided rings. And those little six-sided rings are then arranged in flat plates. And there are weak hydrogen bonds between each one of these groups of plates. So when you write with your pencil on a page, you are actually taking one of these flat collections of graphite rings of carbon and leaving this on the plate, and then these weak bonds between one sheet and the next are broken by your pencil just dragging across the page. So here you've got carbon, and this is similar to charcoal if you pencil sketch in charcoal or you take an art class, something like that. Now, a totally different form or allotrope of carbon is diamond. Diamond is one of the hardest naturally occurring substances, crystalline substances that we have. Same atoms. The chemical formula for graphite is C. The chemical formula for diamond is C. But what's the difference? Well, the difference is how the atoms are put together. Diamonds are formed in what's referred to as a tetrahedral shape. Tetrahedral shape is a triangular shape. Each side of the tetrahedron is a big triangle. And triangles are very strong from a structural engineering format. And that makes diamonds really, really, really strong. If you find a diamond in nature, it has a shape something like this, and it looks very much like the classic diamond you would see on a playing card. And then it is cut in half, and they polish off the bits and pieces and the corners, and there you go. You've got this pretty little diamond that actually goes onto a piece of jewelry. Another form of carbon, another allotrope, was discovered in the 1980s, and scientists were very excited to discover a brand new format of an element that we've known about for hundreds and hundreds of years, and it was named Buckminster fullerene after the architect Buckminster Fuller, who discovered or created geodesic domes. If you've ever been down to Epcot Center in Florida at Disney World, there's the big geodesic dome structure in the middle of Epcot. And because the shape of this is like a big dome or a big soccer ball, they named it after that architect Buckminster Fuller. Since then, there are also nanotubes, which are tubes of carbon, and this has led to a whole industry called nanotechnology. And this is using these various forms of carbon to do amazing and wonderful things with in the world of chemistry. Carbon's not the only element that has different pure forms of it. Phosphorus also has allotropes. Two of the most common are white phosphorus and red phosphorus. White phosphorus has to be stored underwater because of the fact that when it's exposed to air, it will ignite and catch fire immediately. Very often used in tracer bullets for military applications. Red phosphorus, much more benign, and red phosphorus compounds are on the sides of matchbooks. It's kind of a dark red color, and that's where you're going to see it. So doesn't burst into flames, very different color and very different chemical properties. Arsenic has a couple different forms, yellow and gray arsenic, very different structure, how the molecules are put together, but the chemical formula for both of these is As, arsenic. So as we talk about elements, please be aware most elements do not have allotropes. Many do, probably less than 30 elements have common allotropes, but you are going to encounter them sometimes, and they're really interesting things. They all depend upon how the atoms bond to each other if they happen to be identical, like arsenic to arsenic or carbon to carbon. All right, see you later. Bye-bye.